Hi everyone and welcome to our lesson today. Today we are looking at purity of substances. As with all of our lessons, it would be really useful if you had a pen and a piece of paper so that you can work through the activities with us. Our challenge today is to be able to describe how we can use chemical tests to determine the purity of a substance. Our aspire is to be able to explain the results from chemical tests in terms of purity of substances. All of the products currently on the screen use the word pure in their labelling. But what we need to learn today is the difference between pure as a natural resource or pure in terms of substances on a chemical level. None of these are pure. So what does purity mean? The word pure is used frequently in everyday life, but to a chemist, the purity of a substance has a very specific meaning. A pure substance is a single element or compound, not mixed with any other substance. Now, you can test for purity in a quite simple way. Pure elements and compounds will melt and boil at a specific temperature. You might remember from physics looking at the graphs of energy and temperature and seeing that when a substance is changing state, the temperature of that substance does not change until all of that substance has changed state. It's that principle that we use when we are testing for purity. Melting point and boiling point data can be used to distinguish pure substances from mixtures because a mixture will melt or boil over a range of temperatures. So if there's anything making that substance impure, it will change temperature while that state change is happening. So I'm going to insert a video here on testing the purity of aspirin. It shows some equipment that we don't commonly have in school, but it's a very useful piece of equipment that we used a lot in university. I've inserted the YouTube link there onto the screen, so if you want to go and watch the original, you can.
This machine is going to check the purity of aspirin by checking the melting point. The melting point of true aspirin is 135 degrees, so let's see at what temperature our aspirin melts at to see if it is in fact pure aspirin. We have set this up so it's reached 125 degrees, that's 10 degrees below the melting point that we're after, so we don't have to wait too long. We now need to collect some of the aspirin that we have made, so here is that aspirin. This is a capillary tube, a very, very small tube with a hole through the middle, and at the bottom it's closed, so we're going to collect some up. And if you tap, it will gradually get to the bottom. There we go. You can just about see white powder at the bottom now, so that's our aspirin at the bottom of the capillary tube. So, next we need to place it into the contraption. So it's going to go in through the little side door and into the heating chamber. And when you look from above, you can when the camera focuses, you can see the white powder in there. So we'll start heating. The temperature is now at 132 degrees, and you can see that it's starting to melt. 133 degrees, 134 degrees. And that is all melted. We have a look. Ooh. Yeah. There we go. You can just about see that that's now a liquid, so that melted. So it started melting at 132 degrees and finished melting at 134. So bearing in mind that pure aspirin has a melting point of 135, ours is slightly impure because it melted between 132 and 134.
So, using everything that we have done so far, I would like you to have a go at answering a few questions. The first thing I'd like you to do is define the term pure substance. Then I'd like you to tell me how you could use melting points to test whether a substance is pure or a mixture. Then a little bit of a problem-solving one. A sample of paracetamol melted between 164 and 168 degrees Celsius. Is that sample pure? Explain your answer. So you should have something like, a pure substance is a single element or compound not mixed with any other substance. A pure substance will have a fixed melting or boiling point, whereas a mixture will melt and boil over a range of temperatures. The sample is a mixture because it melted over a range of temperatures, and if it was pure, it would have melted at a fixed point. And this is just quoting that melting point that was on the screen as well, 169 degrees C. So now we're going to move on to look at formulations. A formulation is a mixture that has been designed as a useful product. So every component of that mixture will have a purpose. Scientists use different chemicals with specific properties to create a formulation. For example, paint. In paint, we use pigment to provide colour. We use a binder to help the paint attach to an object and form a film when dry. And we also use a solvent to help the pigment and binder spread well and thin them out. The solvent will also be what evaporates away from that paint and leave the pigment and the binder on the wall. So let's have a look at a few more examples in the next few slides, and I'm going to ask you some questions on each one. So the first formulation we're going to look at is nail polish. I'm going to insert a video. It's actually snipped. If you want to watch the whole video, the link is on the screen. And after that clip, I'd like you to tell me what the function of the pigment, the suspension base and the adhesive polymer is.
Today, Orly makes countless nail polish colors and finishes. It all starts with their in-house chemist. Hey girl! Using a variety of pigments, the chemist mixes the hue from scratch. A suspension base is added to distribute the pigments, giving the polish a uniform color. An adhesive polymer is mixed in to ensure the polish actually sticks to your nails and doesn't chip, thank you very much. Orly makes over 5 tons of nail polish every day. This drum of nail polish weighs over 200 pounds. It's hooked up to a filling machine. On the other side of the machine, the bottles await their filling. The glass used to make these bottles is imported from Italy. They're sent down a conveyor belt, single file. First, the metal mixing balls are dropped into the bottles to help keep the product mixed.
So you should have the pigment provides colour, the suspension base evenly distributes the pigment, and the adhesive polymer sticks the polish to the nail and is also what prevents chipping. So let's have a go at another example. Now we're going to look at tablets. Again, I'm going to insert a clip from a video. If you want to watch the whole thing, the link is on the screen. After you've watched that, I'd like you to tell me what the function of the active ingredient is, what the function of the bulking agent is, the binding agent, and the lubricant.
Each year, billions of drugs are made by pharmaceutical companies across the globe. One form they come in are as tablets, where a variety of ingredients are combined with accurate measurement and on a large scale to produce drugs varying from paracetamol and ibuprofen to more specialised drugs fighting cancer or HIV. And their development requires some very precise engineering and a complex combination of ingredients.
The ingredients you need to make a tablet depends on the type of tablet you're making. But firstly, obviously, you need the active ingredients itself. And then you might require a bulking agent, which allows you to increase the volume of the material so a tablet will be a sufficiently large size. The second ingredient you'd need is a binder. This allows it to bind together. Then you'd actually need a degradant, which helps the absorption process, as well as a lubricant, which is required to allow the powder to flow effectively into the tablet press, and also to punch the tablet out after it's been formed. After the ingredients have been put into the bin together, the next stage is to actually mix them all up. So then we have to tumble blend them together to ensure that all the powders are mixed throughout the blend.
So we should have something like, the active ingredient is the drug. If you are taking a paracetamol tablet, the active ingredient will be paracetamol. The bulking agent increases the volume to make the tablets easier to handle. The binding agent ensures the solids stick together and don't crumble. The lubricant makes tablets easier to flow into and remove from presses. And there's also sometimes another ingredient that I'm just going to talk about here. Sometimes sugar or flavouring is added to improve the taste of the tablet. It's to mask the chemical taste of the active ingredient quite often. So the famous one here is Calpol. Calpol's designed to help children take medicine without that nasty taste that they might not like. Okay, so now that we've done some examples, I'm going to give you a few different contexts and I'd like you to tell me whether each context is a formulation or a pure substance, and then I'd like you to explain your answer. So the first one, in lipstick, pigment is added to beeswax and a suspension base. Sometimes perfumes are added to improve the scent. Is this a formulation or a pure substance? And explain your answer. So it's formulation, as it's a specific mixture. Each of those components has a very useful purpose. So our next one. A bottle of pure life water was boiled over a Bunsen flame. The water boiled from 98 to 101 degrees C. Formulation or pure substance? Explain your answer. So it's a formulation again, as it cannot be pure. There is not a fixed boiling point. So now we're going to have a look at how this could look on an exam style question. We'll read through it together and then I'll give you some time to answer. So the table below gives some information on common fuels. You've been given the fuel, the contents, the melting point in degrees C, the flash point and the energy released in megajoules per litre. What we'd like you to do is use the information in the table to name the fuel, which is pure substance. Explain your answer. So why did you choose that fuel to be the pure substance? And then define the term pure substance. So let's have a work through the mark scheme. The pure substance was ethanol. The reason for that is it was the only one that had a fixed melting point. Only pure substances have fixed melting and boiling points. The other fuels have approximate melting points, which means they are mixtures. So that was out of 3 marks. The next one, a pure substance is a single element or compound which is not mixed with any other substances. So that's everything for this video. I will see you in the next one.